Okay, so this is the Chapter 6 Precalculus review. If you're working through it, we'll take a look. First ones here ask you to convert the degree measures into radians, and we're going to express our answer in terms of pi here. So if I have 300 degrees, in order to convert that to radians, I know that for every unit of radians, or pi radians, there is 180 degrees. So using this ratio and just multiplying across will help make my conversion for me. And if I pull up the calculator here, I have 300 divided by 180. And we'll convert that to the simplest fraction. I have 5/3 pi, or 5 pi over 3. And I can do the same thing here for negative 38 degrees. I multiply it by pi radians for every 180 degrees. This will cancel my degrees and leave me with the unit of radians. And if we do the same thing, I have negative 38 negative 38, and we'll just divide by the 180 to change it to a reduced fraction. I should really put radians here. I have negative 19 pi over 90 radians. And we'll do the same thing here for converting radians into degrees, but we flip the ratio. So I'll put this as 180 degrees over pi radians. My radians will cancel there. And pi cancels also, and I really just have negative 180 over 6. This one is negative 30 degrees. Same thing here for number 4. We'll cancel the pi. I have 7 times 180 divided by 20. Is 63 degrees. So using that ratio of pi over 180 or 180 over pi, we'll convert back and forth from degrees to radians. And looking at the arc length here. So I need to find the piece of the circle, that's the arc length, of a circle with a radius of 8 feet that has a central angle of 30 degrees. So if I draw a picture, and I mark this radius, we'll call this 8 feet. I make this 30 degrees. I'm looking for just that piece of arc. Well, a way to think about this is that if I know the circumference of the entire circle, and I know that circumference is diameter times pi, or 2 pi r, and then I'm really just looking for my piece of that circle, and that's 30 degrees out of the total circle. And I know a full circle has 360 degrees. So if I take this 2 pi r, which is 2 pi times my radius of 8, and then multiply it by really the ratio here, 30 degrees out of 360 degrees, that's the piece of the circle, or the piece of the arc that I'm looking for, I'll have my solution. And that doesn't look like it came out right. So let's make sure it followed the proper order of operations. 2 pi times 8, and we'll multiply it by Oh, looks like I had 3 out of 360. Actually go back. Just alter that. And we get 4.2. Our unit is feet. So think of an arc length just as a piece of the circle. So you can find the circumference and then use the ratio of radians to a full circle of 2 pi radians, or degrees to the full 360. That'll calculate the piece of the arc that we're dealing with. And if we look at 6, 7, and 8, we're dealing with our angular velocity and our linear velocity. One thing needed to be added here to the linear velocity. So we put on a radius of 12 inches here. Without it, we couldn't calculate the actual velocity. So you can make that adjustment. That's how you'll see it on the test. But this object makes 22 revolutions in 8 seconds. So if we're talking about how large of an angle or the angular displacement, we're making 22 revolutions. And we know that every revolution of a circle is 2 pi radians. And so that would be the angle that we make, or the angular displacement. In order to calculate the velocity of that, that's what we call omega. Omega is equal to the angular displacement over time. So essentially some form of distance over time. And when we sub this in, I have 44 pi is my theta over, in this case, 8 seconds. So we have 11 pi over 2. And that would be radians per second. Or we could write it as rads per second. And then in order to turn that into the linear velocity is equal to r, the radius, times omega, the angular velocity. So since we now have the r value here, we'll go ahead and fill that in. And I know that the linear velocity v equals 12 times omega. In this case, that was 11 pi over 2. And we get 207.3. In this case, we're now talking inches per second. And let's go to the next page. Now we're getting to the trig portion, graphing the cosine and sine functions. So remember the amplitude, we have that general form. Bx, or b theta, c and sorry, not b, b. So from this we'll get the amplitude. A is for amplitude. So I see that the amplitude is 1/4, and it's the absolute value because it's the distance from the midline. We have an amplitude of 1/4, or 0.25. The period then, the standard period we know is 2 pi, and the period is found by taking 2 pi over b. b in this case is 4, so we get pi over 2. And then the phase shift. The phase shift is found by taking c over b. We can see in this case there is no constant term being added into theta or x. So we have 0 over the b value, so it's 0. I have no phase shift in this function. So there's our amplitude and our period shift, and I have no phase shift. So if we graph that here, negative 1/4 sine of 4x now my period's pi over 2. My amplitude is 1/4. I'm going to go ahead and make this to the fourth and negative 1/4. I need to graph 2 periods, and this goes out to pi over 2, and I have no phase shift. So I'm going to go ahead and double that. So this is going to stretch all the way out to pi. So if I have 2 periods of pi over 2 plus pi over 2 will result in 1 pi, or 2 pi over 2. So we will half that. This would complete 1 period. We half it again and again. So I have 1/8, 2/8, which reduces to 1/4. This would then be 3/8, 4/8, which is a half, 5/8, 6/8, which reduces to 3/4, 7/8, and then you have 8/8, which would be pi. Now the sine function starts at 0. Now remember, this is reflected because I have the negative out front, but 0 reflected stays at 0. And instead of going up to 1, or 1/4 here rather, it goes down to the negative side. Then we're back at 0, up to the positive, down to the negative. And because we segmented our marks as such, split it in half and then half again, makes it pretty easy for us to find the points. And there we have 2 periods of our function. And this problem, 1.5 cosine of 3x plus, sorry, let me screw up just a little bit here. Pi over 2. I'm going to make our adjustments. The amplitude I see is here, 1.5. The period, which is 2 pi over b. b in this case is 3, so that's 2/3 pi. And then I do have a phase shift here, which is c over b. C in this case is 3 pi over 2, and all of that is over 3. So I have this divided by 3, which is going to set it at 3 pi over 6, which is pi over 2. And we need to graph 2 complete cycles of the same thing. So we'll scroll down here. And again, we have an amplitude of 1.5, period, of 2/3 pi. phase shift of pi over 2. So we'll go ahead and graph this. Let me just double check one thing here. Okay. In this phase shift, it's actually negative c over b, so this is actually a shift to the left. Make sure it's the opposite sign here. It's negative c over b. So we're going to slide this left by pi over 2. So I need 2 periods, and it's 2 pi over 3. So if I double it, that's 4 pi over 3. So we'll mark all the way to there on this side. And we'll go ahead and half that. And half of this then would be 2 pi over 3. Half of that would be pi over 3. Half of that would be pi over 6. So I have 1/6, 2/6. This would be 3/6, or pi over 2. 4/6, 5/6. 7/6. I'm sorry, 5/6. This would be 6/6, or pi. 7/6, and then 8/6. And because I know it's shifting by pi over to the left, I'm going to go ahead and mark this at 1/6. So this would be 0. This would be negative pi over 6, negative pi over 3. And because it's shifting 1, using the pi over 2, I'm going to extend this just slightly, mark this at negative pi over 2. And my markings are done by 6, and that will give me a nice placement of my critical points here. So then we mark our graph. The cosine function, sorry, let me put the minimum and maximum on here, up to an amplitude of 1.5 and negative 1.5. No vertical shift on this one, so the center line's still here at the x-axis at 0. And normally I would start up here at 1.5, but because it's shifted by pi over to the left, I'm going to go ahead and move that over here to a negative pi over 2. And then it heads downwards. And kind of missed that one there. There we go. We have 2 cycles of our cosine function, 1.5 times the cosine of 3x plus 3 pi over 2. Now our last problem here is to write the function given the amplitude and the period. And we see it's the cosine graph. I know it falls in the form A, the amplitude, times the cosine, just COS, times B times X, or theta, plus C plus D. Again, make sure you have your 6-5 notes. This then is the amplitude. B helps me find the period. Pi over B. The phase shift comes from negative C over B. Then the vertical shift is from the constant D. And that's notated in your 6-5 notes on the front page. So if I write this in, I know it's y equals 2 times the cosine, because my amplitude is 2. And I have a period of pi. Well, I know that the period is equal to 2 pi over b. And b in this case, let's see, we don't know, but we do know that the period is pi. So I'll go ahead and substitute that value. And we can think of it as simply a proportion. And if I cross multiply, cancel my pi's. In this case, you can use parentheses or not, it doesn't really matter, 2x or 2 times theta. And there we go. If you've got any other questions, feel free to email me over the weekend. You can stop, pause this video. The key is posted on the online calendar. And any final questions, bring the class on Monday and we'll speak briefly and then get tested. Have a great weekend.